I would say I'm privileged and lucky to work within a company where I get to consume like about 100, 120 projects, right? Like we are 4,000 in India. So you can see the diversity of what we do. And out of this experience, I wrote the experience of teams when they take something to prod. And that resulted in an article on Mortal Fowler. So I won't be going through, what's a eval, what's a guardrail, why do you need safety, or about hallucination of any of those, because if you want, I think, everybody knows this by now. What I want to cover in this talk is, let's say if you want to build applications beyond assistants and chatbots, of course, agents, what are the patterns emerging? And I made sure that, I don't start with what is written outside. I want the patterns to emerge out of the projects that we see, right? But the first thing I noticed is there are not that many great patterns coming out, right? Like, and after written the first article, it was like, am I having a writer block? Why am I not seeing any patterns? And then I looked at the games, right? Are there any gamers here? Minecraft? I mean, if you look at the evaluation set of any model or an agentic framework, they all use games, right? Any reason why? It's a small auditorium, you can shout. Why do they all use games to test an agent, right? You're going to use that in your enterprise, strategic thinking. Quite a lot of reasons, but the reason that stood out is, if you're modeling an environment, it's not very easy to model your world or your enterprise, but it's pretty easy and pretty objectively you can model your environment in a game, right? And you can say, this is working, this is not working, right? And with that context, and that's the reason why I picked games. So bear with me. Do people remember this moment? This may give away your age, but this is the first instance of an AI working at a human intelligence or even beating the grandmaster at that time in the game of chess, right? But that's a fact, right? Like, I'm not going to talk too much about the fact, but behind the scene, what was happening is that the researchers built a very custom machine, Deep Blue, and a brute force search, right? And that's how they won the grandmaster that time. So, and then obviously, the world of academics and industry, it's completely divided. One set of group of people are saying, okay, you know what, this is cheating, right? This is not how a human would play chess, right? You are like solving all possible game by sheer brute forcing with a specialized hardware. So a lot of people kind of ignored the approach, right? So much so that nothing great happened for the next 20 years, right? Do people remember AlphaGo? Lee Sedol? And what happened after 20 years? Game of Go is a lot more complicated than chess. So a lot of people thought during this 20-year span in the field of AI that if you want to make an agent better, you need to somehow embody the human thinking in that agent, like have a specialized structure of, how the game is played, how a human would play. But that's not how AlphaGo was built, right? Like back in 1996, there was no concept of learning, right? That was not evolved that much. So it was sheer brute force search. But let's say 20 years later, in 2016, when people from Google built AlphaGo, they made one more addition to sheer search, right? And that is self-play, right? This software would play against itself and learn from its mistakes. So search and self-play, right? Sort of a learning. So what happened? It did beat the master of that time, Lee Sedol, and we all know this, right? I'm going to fast forward now, let's say 2022. Have people heard of this? Do people play diplomacy as a game? Yes, no, it's a strategic game. So Meta, Facebook, they built this Cicero as, so past two or not generative AI, but this one is, right? Under the hood, C0 is built with BERT, if you know BERT. It's the version before the GPT, but it's also a kind of a transformer. So the thing about this is that it has sort of two brains, right? Like a human, like a left and a right. You can think of it like a strategic reasoning and recursive reasoning, and then there is a dialogue model, right? So they always go hand in hand. And I won't say this would beat the master of this game, but it is pretty good. If you are 6 players are playing, and if one of them is AI, you won't even notice that it is AI that is actually playing the game. So it's that level. A human would trust that it is another human that's actually playing this game, right? Which is fantastic. So why am I bringing all the games and learnings in patterns of agentic AI? Here is the bitter lesson learned. If you don't know Richard Sutton, you should please look it up. I think he's one of the fathers of RL. So 70 years of AI, the bitter lesson is this, right? Whenever you want to try to solve a problem with AI agents, we think we should solve it in a way a human would solve the problem, which is fantastic. Another approach is use search and learning. But you may think that, oh, you know what? It's better to do both. But the bitter lesson is that if you spend time in one, that's equivalent to time not spent in the other, right? So the bitter lesson is, even though your human knowledge of a field, right? Like I took the thing of games, but let's say I'm a banker, I'm a retail person, I'm in pharma, healthcare, life science. If you try to build an agent with the human knowledge and the way you would solve, it may work well in the short term, but in the long term, the computational power available to you is going to increase, right? It was Moore's law before, now it is, I don't know what law, GPU scaling law. So what you think is the most brute force algorithm, it's not so intuitive, but over time and time again, like Rich summarizes, and it's a very short 1-page essay. I would encourage you to read it. He argues that you're better off with search and learning as the foundation of how you build an agent, as opposed to like hard coding all your human knowledge, right? So that's the bitter lesson. I want you to keep this in your background, and then I'll go into the patterns. A lot of time. Right, so search and learning, right? What is an agent? I'm not going to even define it. In fact, Simon William, one of the authors of Django, he had this Twitter experiment, and he actually gathered input. There are 200 ways to define what an agent is, based on I'm a product owner, I'm a designer, I'm a database specialist or a tool architect. So you can look it up. So that's the gist of his research and how to define an agent. But here is one thing that is closer to me of what an agent is, but it's a picture, so you can't just define it. Lillian is a researcher in OpenAI, and she blogs a lot about her research. This would resonate to you, right? There is no surprise here. An agent has tools, memory, planning. It acts in an environment. Unlike game, our environment is not very much codified in an agent, but it kind of acts, right? So that's an agent. Now I want to say, what's the big hype, right? Why is there a big hype about agent, agency, and all of that? It basically comes down to this, right? So I am in A, and I have to go to B, which is my goal. One way to do it is an analogy is I have a human knowledge of what steps to take, like these, and I kind of codify in the software, and the software takes the step. That's one way. The promise of agent is you don't have to do it. Let it be search and exploration, right? If you ask me, that is the fundamental truth behind the hype. But it is a hype nonetheless, right? I let you be the judge of Is this a promise now being delivered, or is it still a hype, right? So now the bulk of the talk, what are the patterns that I saw emerging when I was seeing projects across ThoughtWorks India and global, right? Three main categories. I made it in a way that, this should not be a surprise. Do people know this action space? Because the other two are common. Action space is nothing but, the space where like an agent is generating text, then text is an action space. If it is generating JSON, it is a structured action space. If it's producing code, it's a code action space. So that's what is an action space. So based on action space or planning or memory, there are the n number of patterns that you have to pay attention when you're building an agent, right? So let me ask this. We are like, I don't even have to ask this question. Everybody in the room knows the agents, like LLMs can generate pretty good code, right? But then let me ask this, like when you're building agents or GenAI products in general, are you using code for reasoning? Yes or no? No. Then think a lot, because if you are having a very, how do I say, enterprises are even more complicated than games, you need deterministic answers, right? And if it is so deterministic, you're better off with traditional software, coded, compiled, tested software, right? Somehow you want runtime logic to be explored, but you also want it to be deterministic, right? Like you are in this tight spot. Only if you're in that tight spot, you need to use this pattern, right? Like using code as reasoning, right? There is a hello world example here, but let's say you are building a portfolio management, right? Now, if you want to balance your portfolio according to market, we all know this, how market prices, they are like super fluid, known only at the market time. Even though there are like standard algorithms, what strategy to mix and match and what would make sense for your risk profile is known only at runtime, right? You can apply this to your own domain. So if you are in that situation, use code as an action space. So let the model generate code, let it compose your pre-existing deterministic API in a fashion that is only known at runtime, right? So that's code as action. Now, this should raise alarm. If LLM is writing code at runtime and you're going to run it in production, you need to have safety, right? And this is a different kind of safety than your evals and guardrails. This is like, what if that code is compromised, right? What if that code has a third-party API call? And what if? So secured sandboxes are a pattern now, right? Like this means, okay, the first thing that would come to your mind is, let me use a Docker or a container. You can. The downside is, even though containers are light, they are not light enough because your LLM calls are slower. And if you add container overhead of running for every single chat, it's going to be even slower. And hence, what the new modern sandboxes do, they build it on top of Firecracker or a micro VM. So it's much more lighter than your container, but gives you the standard security of your VM, right? So that's sandbox. I know I'm going fast, but yeah, bear with me. I think I have 2 slides where I don't have to talk a lot, and this is one of them. We all know MCPs, fantastic. Anthropic, published this. My only 2 cents on MCP is that it's not a protocol, right? Let's get that straight. It's not a protocol like a TCP or a UDP. It's a spec. It's a JSON spec or a schema, right? It's how you will build client and server and connect. So it's a standard and not a protocol. But again, it's a name, so we stick with the name. And this is also something I don't have to talk a lot. Like lots and lots of tools are there, right? A lot of people ask me, when would I directly use a vector DB and do whatever I want with a DB as opposed to use an MCP? Let's say if there is a service that exposes search via MCP, should I do that or this? My answer has always been, if you need to take an action, go via the MCP route. If you want to consume sources of data from more than one source, go down the route of, you have to maintain the central repository, right? So that's the take. Now the big question, right? What actually separates us from, or rather, let's say there is someone who's like a amateur and someone who's like really professional in what he or she does. Like, what actually separates them, right? Like, it's if you give them a task, it's like how good I can break it down into smaller and smaller things, right? Like, let's say you ask somebody to solve a problem, like you can go from A to B in your head and solve and write the answer directly, or you can methodologically break it down into really, really small steps and solve each of them, right? So if you ask LLM today, let's say anything, and I honestly feel asking an agent to book a ticket is a wrong example. That's my personal opinion, because let's do it, right? Let's accept it. Planning a holiday is not a checklist, it's an experience. And if you have to describe everything that you want to do, you can do it faster than the agent, right? But let's keep the planning your holiday aside. Like, if you have to plan anything else, LLMs really, really suck at it right now, right? Like, and this statement is not absolute. Like, tomorrow they may get better. But the understanding is, yes, there are lots of ways to decompose a problem with prompting techniques, right? Like chain of thought, react, and program of thought. And there are also lots of ways to plan multiple things, right? Like, I want 2-3 planners and I'm going to pick the best one, right? We have all seen this tree of thoughts and graph of thought. And then there is the third category of planning, which is basically saying, I'm going to do this, or I've done this. I want someone else to give me a feedback. Is this good? Am I progressing towards the goal or not, right? This reflection is really key, because unless you guide, like in that agentic A to B traversal, unless you guide the LLM, it's going to go into the wrong path, right? So those are the 3 big categories of planning. But like I said, okay, let me take a step back. What is the planner that we all use in our professional day-to-day life as a computer science developer professional? If I ask, sorry, what is the planner? We use this, like, I can bet every single person would have at least used it once a day. Sorry? Yeah. Jira is not a planner. Jira, okay, how do I put it? Jira takes your plan. There is a planner that you use every single day. And Outlook, calendar, we all use databases, all right? You write select star from blah, there is a planner behind the query, right? The reason why I take this as the best planner out there is, if you understand how the data is organized, if there is no planner, even your best database in the world will not work, right? Imagine there is now a report. Let's say you have 10 petabytes of storage and you're making a query, right? Guess the amount of data it usually scans. The statistic says any kind of analytical query, irrespective of your database size, the DB would approximately scan 100 MB, right? And the reason for that is the efficiency of the planner, right? It knows where the data is, it knows where to do the join, it knows where to do an in-memory join, so on and so forth, right? So the point here is, planners have been around for a way long time, right? Like 30, 40 years. So if you're in a domain where you are like, I'm in logistics, I want the best path for my driver, don't ask that to an LLM, right? Use an external planner, right? And there are a couple of things, like PDDL is planning domain definition language. There are a number of, you get the idea, right? Like how you integrated tools, now you can integrate a planner so that the LLM gets a very nuanced plan, and then the success of your agent increases because it's now very much prominent. Right, 7 minutes. And then it goes without saying, if you're planning, if you're not incorporating your own feedback, your own experience, then you are almost answering as if you're closing your eyes and you're opening your eyes every single time, right? There is no memory, right? So use memory with planning, right? So that's the third one. I'll cover this later. Right, if you want to know more about planning, this is probably the best paper that summarizes all the planners I've spoken. You can please read this. It's a light paper. It's a survey, so it should be easily composable. Right. Memory, right? Here is the catch, right? Now I'm going to show my age again. So how many of you have worked with DOS? Do you all remember upper memory 64 KB limit and such? Don't you think we have the same problem now? I have a context window that's 8K and that's all I have, right? In a way, old is new again. LLM is the new operating system. Now I have RAM, which is very limited, which is the context window, right? Now, the best way to look at this is like, how did OS solve this problem with virtual memory? And that's exactly I did jump the gun. So that's exactly how MemGPT does organize its memory. So if you're talking about something that is not in the context window, it paginates out what is in the context window, which is not relevant, and takes the relevant into the context so that, you don't run out of the context space, right? It's a super clever way, again, channeling 50 years of wisdom or even more in operating system to manage the context length, right? So when I wrote this article, a lot of people replied in LinkedIn saying, you wrote extensively about RAG, and RAG is dead because the context window is like now 2 million tokens or something. Here is the catch. If you have a larger context, does not mean you can fit the entire DB in the context, right? So there is again a brilliant paper called Lost in the Middle. Basically means LLM remembers what you said in the beginning and what you said in the end. Everything in the middle, you're lucky if it pays attention, right? And that's why you have to keep context like very clean, what is there in the context. So MemGPT is a good pattern. External memory, we all know this, right? If you're building RAG, of course I will have a vector DB. You can have a graph DB, like so on and so forth. So this is known. Now I'm going to talk about two patterns that are coming out from research. So it's not mainstream yet, right? Let's say, why is this good? Yeah. Let's say I'm inferring something at runtime, right? And if I want the model to remember and memorize at runtime, which is otherwise called test time, otherwise called inference time, right? None of the current models can do this, right? The only option is you can fine tune to get that memory, but that's not runtime. Or you can have in-context learning. Again, it's only limited to your context window. So this is, you can almost think of the next iteration of attention is all you need from Google. This is called Titan. So it basically gives an architecture where a transformer has memory, right? So the way it works is, let's say, how do we all remember things? Like if you think a talk is interesting and it is a surprise to you, you will remember it, right? It's always based on surprises, because if you expected something to happen, if it didn't go through your plan, you will remember it. And that's exactly how this model does, right? Like if it sees something that is not seen before in the test time, it will remember, right? And the best part about Titan's paper is there is also an algorithm to forget things, right? So it will also forget if it is not recalled over a period of time. So that's Titan. I think this one is even more interesting. This one is from Microsoft. It's called knowledge base into the model. Let's imagine we are doing RAG now with external pipeline. Imagine that RAG is inside your model, right? Imagine if somehow you can infuse your enterprise knowledge base into the model itself, right? Like, so if you talk about a topic and if it is not there in the context window, the model itself will load and answer the question, right? So that is KB-LAM. It's pretty fascinating. Of course, I don't have time to go into how it works. But I would say one thing, right? The catch is this. Do people know the cost of attention, the quadratic complexity. Yes, no. Let's say there are 10 words in the context, right? And then it needs so much memory. Now, if 10 words become 100, the amount of RAM does not grow linearly. In fact, it is 100 times 100, because every word in the context has, or rather every token needs to have its own mapping against every other token. So the KBLAM, what it addresses is, that's no longer true. So if you are infusing external knowledge into the model, your question or your prompt will have the quadratic memory complexity, but not the knowledge, right? Like if you're infusing a fact, that's a fact, just use the fact, right? So there's lots of optimization here. So that's KBLAM. Now, I know I have 1 minute, and here is my message. I think the previous speaker spoke about workflows or patterns. I still think this is the best blog by Anthropic of how to build agents. They basically say 99% or 90%, you only need workflows or pipelines. That 1% scenario is where you need to explore. You need code act, or you need tools or something where you really have agency. So I would say that, if this is your application going from A to B, right? If you think there is something interesting here that you need to explore, use an agent, right? But otherwise, it's always going to be point A to point B, right? And yeah, so use agents where needed. Don't forget about search and learning, right? That's pretty much what I have.